Hi, welcome everyone. Thank you for being here in such amazing numbers. I'm a little stunned by this. I'm Nicolai Parlog. I'm a Java developer advocate at Oracle, and today it's going to be you, me, and modern Java in action. We're going to run through a ton of features with some live coding. So we'll implement a little GitHub crawler, and I'll aggressively use and arguably abuse and overuse all kinds of Java features. This is not meant as a, this is how you should do it. This is meant as a, this is what it could look like, and then you pick and choose. This is a showcase, not a tutorial. I cannot stress this enough. I will not have the time to explain these features in any decent amount of detail. That means if you've never seen some of those features, this might seem weird or out of left field, and that's fine. Like if you're willing to work through that, then that's good. But if you'd really rather have like a reasoned explanation about everything you're seeing, then this is probably not going to be the talk for you. Just for fun, who has been either at my deep dive on Monday morning or at any other of the sessions going into pattern matching or virtual threads or something like that? That's great. That's at least half the audience. So that makes me believe that most of you are well prepared. If you want to dive deeper, the Java YouTube channel has a ton of videos on all of this good stuff. The code is also online. Do read the README, the documentation. Without that, like you wouldn't know what's going on. And if you have any questions, you can ask them at any time. Now, I'm not known for pausing or maybe even breathing while I talk, and I will not look up a whole lot because I'm coding. So just be loud and yell, and I'll hope that I can hear you, and then we'll take it from there. Oh, and if I make a mistake and you spot it, also, please do help me out. OK, so as I said, we're going to implement a GitHub crawler. If you've been there on Monday, you already know this example a tiny bit. The idea here is that we connect to a URL. We identify what kind of page it is. Ideally, it's a GitHub page, because otherwise, why are we crawling it? We identify the interesting section, which for a pull request, for example, is the conversation. We identify outgoing links, and then for each link, we start at step 1. Now, most of this crawling and understanding HTML and all of that, that's in code that we're not going to write, because that part is not super interesting. We're going to deal with things around that. Specifically, we're going to print some statistics, print a page list, and we're going to show those pages on localhost, which are, of course, all very simple features. But they're a stand-in for more complex features that, since we're going to do pattern matching and data-oriented programming, complex features that you would otherwise not want to implement on these types, even though for these specific operations, you probably get away with that. I want to go a little bit over the game plan so you're not entirely lost. We're going to use as a domain model records and sealed interfaces. And we're going to write our operations, not as methods on those interfaces and records, but outside of them in extra classes. And we're going to use pattern matching to take our data apart. We're going to use the HTTP client that was added in JDK 11 to fetch the stuff from GitHub. And we're going to use virtual threads and structured concurrency to ask for all the pages in parallel. Which you could argue, by the way, does not make too much sense here. Probably GitHub is not going to give us like 100 connections at the same time. But again, it's a stand-in for something where this makes a bit more sense. We're going to present the results. Originally, I wanted to format this with text blocks and then string templates. There's a whole section here about string templates. That proposal went the way of the dodo, so we're not going to look at that. We're basically just going to skip that step because I don't think I need to show you text blocks. They're not that fancy. But we're going to use a simple file server to host that locally. And we're going to use modules, of course, to get a reliable application. And with that, I just want to get started. So at the moment, this project has very little. There's a GitHub crawl class here that does nothing, or almost nothing. And we're going to start with the domain model, as I mentioned. So let's start by creating the first record. I want to start with an external page, meaning some of the GitHub pages linked to some other page, maybe Wikipedia, maybe a project page. We're going to stop crawling there, but we still want to register that page. Those pages all have a URI. Oh, macOS is struggling here with many screens. OK, and it's going to have some content. And with the record, you could be done now, right? This defines a record. We get a lot of stuff for free now, but it's very common that you want to make sure that your data has the right shape. And the constructor is the right place for that. The compact constructor, you do stuff like, for example, making sure things are null when they're not supposed to be. That's one thing that we could do here, probably for both of those fields. Let's do the same for content. And then in this specific case, we could probably also check that, come on, there we go, that the content isn't empty. For example, text or blank, we should use is blank since that was introduced because it has better handling of white space. And illegal argument exception probably with a good error message let's say to do, right? That's the most common error message I get. And that verifies that the data is in the right shape. That's very important. If you do use records, please do that. Make sure that a record instance is only successfully created when it adheres by the invariants that are important to you. Now, we also get an equals and hash code, and it will by default use all those fields. But since the URL is hopefully kind of unique, we could argue maybe you want to have an equals and a hash code based on that. And you can add that, right? All the things you get generated, like the constructor, like equals and hash code, we can override all of that. In this case, we should. And this also gives me the chance to show you a little bit of a cooler implementation of equals. We can do the if this equals O check if we really want to. Well, it's not, oh, sorry, not if, return. So return this. And then we can use the instance of pattern matching here. Now, instance of in equals, for some of you, there are probably some alarm bells ringing. That's really only reliably safe, unless you jump through a lot of extra hoops. If the class is final, records are final, so that's perfectly fine here. We're going to ask if O is an instance of external page, let's call it other, and if it is, we're going to do the equals on, we can just pick this one down here. There we go, for laziness sake. Oh, I should have called it that, apparently. And there we go. And that collapses all of that into the sync check. And if you would have more fields to check, you could just amend them here. So I think that's a very decent way to write that. And I hope that our IDEs will soon help us create those. OK, let's have another one. We're going to have another record. In this case, we're going to have a GitHub PR page. It has a certain amount of similarities, which I'm just going to copy paste. There we go. So it's also going to have some content. And then for a GitHub page, we want to find out to what other pages it links. So we want to have those links here. And for now, we're going to use a set of URI for that. We're later going to get a better abstraction that we're going to use here. And then all GitHub pull request pages also have a pull request number. And now, again, definitely, we would want to construct it here that has all kinds of checks. In this case, the pull request number is probably supposed to be larger than 0. So that, for example, would be an additional check we could place here. But one thing I want to drive home here is that usually you want to have your records be immutable. Records are already shallowly immutable, meaning nobody can reassign the URL and the content or the links. But if somebody gives me a hash set of URIs for links, then that hash set is, of course, still mutable. And by default, you should avoid that. We'll later see an instance where I'll intentionally go the other way, but it should be an intentional choice. So here, I do not want to do that. So I want to make sure that I get an immutable copy of the links. And for the collections in the JDK, there are now immutable copies for many of those. So that's kind of straightforward. But if this references something that is a mutable object from your domain, you should think through the implications of that, whether you want to create an immutable view of that, or not view, an immutable version of that. I'll leave that to you. We could also implement equals and hash code here, but you've already seen me do it. So let's not repeat that. What I do want to do now, though, is go to the next step. And because I'm not going to type out every record, every type all the time, I'm just going to throw away everything I just did, which includes, by the way, I already made the first mistake by not having the right package there, and checking out the next commit. So now we have these 4 types, the 4 records. 2 of them we've already seen, and there are 2 more now. Now, you could think that, hey, data-oriented programming tells us to model the data, and we kind of modeled the data. Those are the 4 kinds of pages we're interested in, so we're all done. And that is halfway true, but the other half is that there are certain relationships between these pages that we have not yet expressed. So first of all, we can start by thinking about a top-level abstraction. Let's call it a page. And that page, probably all pages have a URL, right? So we put the URL here, and there we go. Now, this page does not allow random implementations. When we think about what I'm connecting to a page, what could happen? And for this kind of modeling, what I want to do here is I want to limit the number of implementing classes. I want to say when I connect to a page, it's either going to be successful or it's going to be an error. Successful, wait, permits successful page. There we go. OK, nice. And error page already exists. That's the record. And not by coincidence, it does have the right accessor. So this URL accessor is automatically fulfilled by the accessor we get for this component. Again, not a coincidence. So that's good. let's go down the, it doesn't implement the interface yet. We'll fix that. Let's go down the tree and let's create more interfaces. What is a successful page? Success, yes. Okay. Oh, let's see. IntelliJ, oh, yeah. So I'm not good on a Mac keyboard, but I found that hotkey, so that's good. I'm proud of that. Good. Oh, see, there we go. We're going to make this sealed as well, and we're going to permit public sealed interface, successful page. Okay, permits, there we go. Successful page load means, well, we connect it to a page. What could it be? It could either be a GitHub page or an external page. And then all of these pages have content. Now, I'm not going to use these specific accessors ever in the code that I'm writing here, but it does make sense to think through what the contract is for these interfaces. That said, it is not uncommon for these interfaces to be empty. That sounds kind of weird, right? Why would an interface, like a sealed interface without any methods? But this sealing here, this permission of what subtypes there are parts of the contract of an interface. So it is reasonable to have a sealed interface with no methods, because its contract is not, I have this functionality. Its contract is, it's either this or that. A GitHub page, for now, is either a GitHub issue page that we already have, or a GitHub pull request page that we also already have, right? And then here, they all have a set of, and now we can use our new abstraction, a set of page of outgoing links. And because I'm a lazy person, don't want to bore you with too much implementation detail, I'm going to copy paste another method that has a few interesting things to show though. So it's a default method here. Let me quickly fix all the compile errors that I just got in here. Yes, and yes, and yes. Okay, subtree means give me a stream that iterates through the subtree. So we're pretending that this is a tree, which it's not really because there's backlinks, but we can ignore that. So what we're doing here is we're saying, and again, you don't have to read the code to understand it. I'm just telling you, gives you a stream of all the pages that are reachable from that page. And I have to do some deduplication here because it can have backlinks. But what I want to show you here is something that was added with sequence and collections, which is remove first, for example. That's something new. All lists have that. Certain kinds of sets have that. Remove first, remove last, get first, get last, add first, add last. And then also, since it does have an order, you can reverse that order, which is what I'm doing here. So you just have a set, and then you just on the set say, I want to have the set that's the other way around. And that's what I'm doing here. Okay, so that's a little bit of an API that has been added recently. We will actually use this method, so that's why I'm putting it here. Okay, now we can go through the hassle of implementing all these interfaces and all these classes. I'm just going to do it once, though it's not terribly important. We're going to make it implement this. And now, interestingly enough, this doesn't work anymore, right? But it makes sense. It's the wrong type. So this component, set of URI links, now wants to fulfill the method on the interface. It wants to fulfill this method. But the generic type doesn't align, which is correct, right? Like I wanted to have a better abstraction here anyway, so this is the right choice. Okay, I'm not going to go through all the other ones. That is more of the same. We're now going to take it to the next step, and we're now going to start working on some operations. So we just got a new package here, which does pretty and statistician. Let's just start implementing stuff here. So the task of a statistician is get a bunch of pages, or rather get one page that you interpret as a root page, meaning as the root of a subtree of a tree, then go through the entire tree and just count. Just count what kind of pages I have. So again, this is a stand-in for a more complex operation. This is kind of trivial and arguably doesn't need to be outside of the interface just for demonstration purposes. And the way I'm doing this is I'm saying, okay, evaluate this tree, here's a page. And now remember that the pages that have outgoing links, that have this subtree method, that is only true for the GitHub pages. And that makes sense, right? Because I didn't want to track this for external pages. For external pages, I'm not going to hunt for more links. So this is why I'm doing the instance of check here. I'm making sure that I'm dealing with a general case. And what I'm implementing here is basically a kind of dynamic dispatch where I'm saying, well, if it's of the right type, I want to do this operation. But if it's, well, of the right type is the wrong phrasing. If it's of that type, I want to do this operation. And if it's on the other type, I just evaluate that page. Okay, so how does the evaluation work? That is super simple. We switch over the page. And then we just say, well, in case it's a GitHub issue page, we can just increment the number of issues. And now we're going to do this for the other ones as well. And you might already see that IntelliJ is telling me that there's something that I'm not using. Oh, I forgot the case. I'm not using the variable there. So if you've been in other presentations, what should I be using here instead? Underscore. Great. Yeah, the unnamed pattern, exactly. Let's do this right away. Number of external links, I guess. And now we have the error page. Okay. Right, so that, I guess that makes sense. Again, a little bit weird that it's outside, but it makes sense. We create a statistician, we run through the subtree, we count numbers up, and in the end, when we're done, we put them into this little record to report them, but that doesn't matter. This is the important part I wanted to show you, and yes, if you don't need something, we're going to use the underscore now. Okay, for a somewhat less trivial, but not much operation, let's go to pretty. So here, by the way, I do not have that check implemented yet. The check that I have up here, this one. I have a bug in line 42. Number of errors, yes, absolutely. It wouldn't matter, but good that we fix it. Thank you. Okay, so what I want to say is that this check here, I could use the same one here. I would have to, this is root page now, let me see to line the variable names. And then also this if is not entirely right. We're going to get there though in a second. But I want to talk about something else. So I want to create a page list here, meaning down here I have a method that somehow turns each page into a string that looks nice, and up there I want to create the list for all the pages. And again, I'm in this situation, well, if it's an error page, for example, or an external page, I don't even have any other pages. So for that case, I just want to return the page name. So here I would just basically say return the page name of the root page. But when you're coding, there's often a situation where one case is the weird error case and the other case is the good case. In those situations, I don't actually like so much to have them represented in an if that goes this way or that way. Because to me, an if always looks like both of those are equally valid. Whereas I usually like to handle error cases first. And we can actually do this. Now, we don't, again, I think we come into the overuse or abuse part here. So, be my guest if you say this is awkward, we're not going to do that. But here I'm going to say, well, if it's not a root page, if it's not a GitHub page, I'm just going to return that page name. And now down here, I'm in the good case. So down here, I can use this. It's in scope. It's in scope here, the GH page, because if it is indeed a GitHub page, then if it's not a GitHub page, we walked, the first if already returned us and threw us out of the method. So down here, it definitely is a GitHub page. So we're free to use it. So let's do that. This is going to be page name, and then a to list, and oh no, so we need to join this into a string, right? Yes, we need to join this into a string. And I hear a lot of people coughing, like I'm not the only one, right? Anybody needs? No? Okay, just me. Okay, so I apologize to the sound people for having a pastille in my mouth. Right, so now we're streaming through a subtree and we're turning each page into a name. Now we just need to implement this. This is similar to before, but now we're going to use switch as an expression. So that's good. Then we see that version as well. And now we go the same cases. Let's start with the issue page. And then let's just say, in this case, we call it issue number, and then we go issue dot number. Okay, so that's nice and it works. I mean, imagine the other cases there as well, right? That's good and it works, but there's something we could do to make this a little more elegant. And if you've been in other talks, you know where I'm getting at. Any idea? Somebody said yield. No, we don't need a yield here. Just GitHub issue page was a record, just saying. Destructuring, exactly. So we can use this reference and then take stuff here. But what we can also do, we can say, no. Let me just get the stuff right away. So I have here the URL and the content and the links, and here I have the number. And on the right-hand side, I only want to use the number. And again, now we're in the situation, this is all very pointless, right? So again, we can use the underscore and do this. And so this now means, if you look at the left-hand side, you will see immediately what I care about. And you don't see what I'm doing with it. To see what I'm doing with it, you have to look at the right-hand side. But on the left-hand side, you see what I care about. I care about it's an issue page, and I care about its number. And we can now do the same things for the pull request page, for the external page. I'm just going to add one more case to not bore you too much. So let's say for the external page, we take it apart. The first one was the URL. That's the one we're caring about here. And then the second one was the content. We don't care about that here. And now we can say something like, let's say external URL. I think get host name is what I usually use here. Get host. Yeah. And that's kind of funny now, right? Because on the left-hand side, I'm all like, oh yeah, I'm taking things apart to focus on what I need. But then on the right-hand side, I'm saying, yeah, I don't really care about the whole URL, just the host. Would be nice if I would be able to take the URL apart as well, right? But this class is super old, has nothing to do with, sorry, it's a URI class actually, but still old. There isn't a record, doesn't come with deconstruction, except maybe it will in the future. There is a possibility that we'll be able to add deconstruction patterns to classes. I'm not sure whether this one would qualify, but at least now, from me using it for this exact demo, I feel like it should. So we might be able to then take this further apart. Okay, I will not add the other two cases here. As I said, that is somewhat boring. So I'm just going to go with the next commit. And now we're going to start to go into operations a bit, sorry, into other things than pattern matching. But before we get there, one quick thing I want to add is another record. So there's a bunch of errors here. So this is, again, I'm checking out this code because much of the code isn't that burningly interesting. I want to focus on the interesting parts. And I left those as compile errors or to-dos. This is one. I have a page with links here. I'm going to create a record for that. I'm going to tell you why I need that. So while I'm resolving pages, there's a situation where I already got the URL, I got the content, I got everything I need, I got the issue number, but I still have to trawl through the HTML to find all the links. How do I do that? Well, first of all, I collect them really as URLs or URIs, because I have not resolved them to a page yet. But also, since I'm collecting them, I want to put them into a mutable set, right? Or I need to add things as I go. So instead of wondering, okay, so I have this half-prepared page here, and I have also this set of URLs that I'm mutating, how can I return those? I cannot have two return values. Just create on-the-fly records. The records I created initially were part of my domain. I really cared about them a lot, made sure that the constructor checks all kinds of things. That is not at all necessary. You can just be like, I need a record just locally here for a bit. So sure, let's just do that. So we have a record here that has a page. Oh, sorry. That has a page. And then, that's bound to happen sooner or later. There we go, okay. And it has a set of URIs. And the interesting part here is, that's what I mentioned earlier. Now I really do care about these links being mutable. I want them to be mutable because I want to add stuff. And that's fine too, right? There's something that forbids this. You should just make a conscious decision. In this case, I want to create a new hash set. So no matter what you give me, it's going to be mutable after. And I also know, by the way, that when I initially create this, I often don't have a set yet, and I don't want to create an empty set and push it in. Why not add an additional constructor? That's something I haven't done before, but this is entirely possible. So you don't need just one constructor and a record. You can have several constructors, but what you need to do here is what could be called constructor chaining or telescoping constructors, meaning unlike in a class where you can have several constructors that all assign fields individually and basically all do their own thing, this is not possible with records. There's one constructor that does the field assigning, every other one must forward to that one. That also means all your checks should go to that constructor and everything else should just do the minimum amount that is necessary to guard the invariance. Okay, so let's have just this one, and IntelliJ already does the right thing, puts an empty set here. So that's all good. I have an additional constructor now. Okay, with that out of the way, let's be done with records and pattern matching, and let's do something else, which people do not maybe enjoy quite that much, but I think is also very important. I want to show you something. Maybe let's pick this example here. I have an import here. I have a bunch of imports that I know I will be needing. And look at these. These all work fine. Well, this one doesn't. This is a JDK class. Why would it not be found? Okay, people immediately said modules. I guess that they've been hurt by this. Yes, absolutely. So I have a module info down here. and it doesn't declare any dependencies. So all I'm seeing is the Java base module. But I do want to have more dependencies. So yeah, let's just add this. And then I have the same error here again because I have a dependency on JSoup for the whole HTML parsing. So let's depend on this as well. When people tell you that the module system is hard to use, we're done. I mean, you code, all you need is your code to be this small. But more seriously, the work with the module system, specifically with tool support, is, I think, the work is amenable. It's not like a huge burden. And the thing is, it's a seatbelt. You're not going to easily measure how often it saved your, pardon my French, how often it saved your ass, but it will. So I can only recommend to do use the module system for safety, like strong encapsulation, reliable configuration. We're not going to get into that. We've just used it here, so that will be enough for now. If you're interested in this, I will have my book up later, so you can read more about that. Okay, the next thing we want to do is we want to actually start connecting to GitHub. We have not done this before. Let's do this now. For that, we're going to use the HTTP client that was added in JDK 11. This is the HTTP client library is big on immutability. The idea here is that you create immutable objects. That's not entirely true because they have some internal state, but they hide that really well. You create clients, even requests, that you can then share across threads, right? So we create one client here, and then you make that usable elsewhere. So they all follow the builder pattern. So we're going to use a new builder, and then we can do all kinds of things: authentication, timeouts, cookie handling, executors. We can configure all kinds of things. We need none of that here. So we're going to go with build, and if that seems too complicated, there's even a new HTTP client helper method for this. So that's good. We pass the client into the page tree factory, and this one gets it here, and down here it wants to use that. So down here we have the task to take the URL, use the client and the URL somehow to connect to GitHub, get the response back, and take the body out of the response and return that as a string. And then the rest of the thing that I'm not showing you will do like HTML parsing and figuring out what's the interesting stuff and all of that. Okay, so what we want to do is we want to have a request somehow, and then we basically want to say return client send the request. That's basically what we want to do. Now let's get this to compile. We're going to get HTTP request. We're going to get a new builder. We pass the URL here. And now again, we have the chance to do all kinds of additional configuration. This would, like in the cases where it collides, this would override the client configuration, right? So if we set different timeouts, for example, here, it would override that. We don't need to call get. Get is the default, but I kind of like seeing it there. But you know, your mileage may vary. Both is fine. We're done. We build it now. So that's good. We build our request, and again, we don't have to build it here necessarily. In our use case, that makes sense. But if you know that there's a specific service that you need to connect to again and again, and there's some specific configuration, you can create a request that has all the headers and all the other configuration that you want, and then you can create a mutable builder copy of it, change the one thing you need to change in your specific place, and then use that. So there's one place that configures it in general, and then maybe in a couple different use sites, you just add the one thing, like the URL, for example, or the specific user ID or whatever that you care about. And so then you don't need to repeat the configuration in different places. Okay, this doesn't work yet. We're sending this request, but the API is aware of the fact that requests but also response bodies can be too large to handle in one thing. It has a concept called body handlers, and it wants a body handler that tells it what to do with the body. And we're going to use a very simple one of string that says, give me the entire body back in one. I want to have it all the bytes at once in one piece. So basically it waits until the response is done, and then it turns it into a string. And that's why body will return string. So this body handlers has a T, a generic T, and then body will return that T. So that's how I get this string. And now we're all good. Okay. So we've done that. As I said before, up there is some parsing and resolving and blah, blah, blah. There's some caching going on because it turns out that a lot of pages link to the same pages, and I don't want to request them all at once, specifically not on conference Wi-Fi. So that's all logic that's up there. Down here, the next thing or the last thing really we need to do is to say, okay, I got all these links here that are coming in. And what I want to do, I want to stream them basically. And then I want to map for each link, please. There's a create page method up there that takes this link, and then the depth. This depth is at some point this depth is decreased by 1. It just means don't crawl off GitHub. You tell the crawler start in that page, and the depth is 10, and then it goes until it reaches depth 10, Again, so you don't crawl off GitHub. And somewhere there's a depth minus minus, hopefully hiding in the code. Okay, so this is conceptually what you want to do, right? You want to say stream over all the links, and for each link do a create page. Now, this has a red underline because this throws an exception. Specifically, it also throws this interrupted exception. It's basically this one. It percolates up to the create page method, and that comes from client send, because this sending of the request is a blocking call. It sits there and waits until the response comes back, and then it does its thing. There is also a send async if you prefer that, but what we're going to use here is we're going to use virtual threads. So we don't care that it's blocking, because that's all fine for us. Okay, so we need a structured task scope. This API is going to change in JDK 24, I presume, I think, as a preview. So the structured task scope API is still in preview, and it will change for 24 probably. So don't read too much into the details. What I'm doing here is I'm creating a task scope which is in charge of managing all my subtasks down here. I will show you how it does that. And the shutdown on failure means if one of those tasks doesn't do its thing right, if one of those complains and throws an error, then the whole thing will be cancelled. And there are different ways to do this, right? This might be correct for your use case, but there are different strategies here, and it's very straightforward to implement your own strategy if you have something more complicated. So you can turn that error behavior, failure behavior, into a reusable component. But shutdown on failure is perfect here. That's what I want to do, because there's not supposed to be any errors. We have this error page record because every error that should happen when I'm connecting to something or parsing something should always end up in an error page. So this should really never happen, which we're going to express in a minute in the catch clause. Okay, so this is not how this works though. This stream would still just do the first thing and then block and do the next thing and block. So what we're instead do, we're going to go to the scope and say, please fork a new task. And that task does this. This task, so it's a callable, right? Create the page. A callable can throw an exception. That's why this is fine. And then we're done with that now. We're going to set this. I don't know, we can collect in a list. The important thing here is that this is fast in the sense it just fires off all those requests at once. And that's that, right? Meaning fast, it doesn't do anything blocking. It's just do this, do this, do this. Starts new virtual threads for that, but even the virtual thread launch, but that one actually is part of this loop, but everything after that, like what they actually do connecting, that's not part of this anymore, right? So as soon as we reach this line of code, we have fired off all the subtasks, but we now need to wait for them. And this is how it's done at the moment. Again, this will probably change. Join means wait until everything's done. Throw if failed means, and if there was an error, now is the time to throw an exception. So that's what it does here. We're going to add a catch clause. And as I said, this should be a new legal state exception, because this should not happen. Error page should have caught this. Who has ever debugged a problem and landed at a throw exception? This can't happen? Yes? Okay, good. So we've all been there, right? Now you know how this works. People like me make stupid decisions on the fly. Okay, good. We are almost done now. We have to get the results. So we joined all the tasks. They're all done now. We can now immediately get the tasks, so the results. So if you have a completable future and you call get on it, that call might take a while because you're not guaranteed that the completable future already completed. But because we call join, this is different here. So that's all good. We can just get the subtasks. And we're going to stream again. And we're going to map with a subtask get. There we go. And now we're going to turn this into a set. There we go. IntelliJ knows what I want to do. And we're done. And this is all the virtual threads and structured concurrency we're going to see in this talk. And that's typical, right? In many of your applications, you don't deal daily with thread pools and everything. I mean, some people do, but for most of it, we're more focused on business logic because the threading system is not something you change daily. And so that means that virtual threads is also not something you're probably going to interact with a whole lot. Every time you think, oh, I want to do a couple things at the same time that take a moment, then there's a situation where you want to use virtual threads. But if you're just doing in-memory domain logic, then that's not that likely. Okay. I want to show you something pretty cool, though. While this runs, which will probably take a second. Let's see. There we go. Okay. I want to copy this command. Come on. There we are. Okay. And quickly execute it. I was not in time. What do you mean no such problem? Was it that fast, the Wi-Fi? I can set a breakpoint, but I'd rather not because that takes extra time. Come on. No! I hit the... Okay, let's see. Oh! I'm confused. So the reason why it ends so fast is because it's just doing the one request. I forgot to copy the links in my page with the links record.
It's always an empty sentence.
Yeah, on construction it is. But it will then be added after. So on construction it's an empty set.
Okay.
Oh, wait. Yes, no. Yeah. Excellent. Thank you very much. Wow, you get good eyes. Okay, now this is still too fast though. Come on. How is the internet Wi-Fi screwing me by being too fast? the conference Wi-Fi. Yes. Okay, we got it. Okay, so what was I trying to do there is I want to create a thread dump. And the reason why I had to copy paste something is because I don't know what what the process ID will be in advance. So I wrote a little bit of a system out print and it says this is my process ID, here's the command, execute it to get the thread dump. Okay, why do I want a thread dump? In structured concurrency, one of the really cool things here is the observability that it grants you. So if you have a thread pool, then what usually happens is you have a thread, you have another thread, both of them live for a very long time, potentially through your entire application lifetime, and they meet like strangers in the night, right? Passing love letters about what they want each other to do, and then they give results back, they go back into a pool and come out. This is not how virtual threads would work. A virtual thread like this is, if this runs in a virtual thread, it sits here, well, actually it sits here and waits for all of these other subtasks to start their thing and then to finish their thing, and only once that has happened will it self continue. And that means that its lifetime is strictly larger than the lifetime of these other threads. And that allows for a parent-child relationship. This thread that waits in join is the parent of all these little threads doing something else here. And that is visible in the thread dump. So we have a JSON thread dump here. And if you look, for example, for the HTTP something, there's a sector manager, we'll find some tasks sooner or later. There we go, okay. So this is there we go. So this is a thread that is currently waiting for GitHub to reply. And it went into all this stuff and it sits in virtual thread park, and that's pretty cool. Okay, so far so good. It has an owner. Now, let's go search for that owner. Thread ID 80. This is its owner, and look where it's sitting. It's sitting in join. So now you debug, you put a breakpoint somewhere, you're like, okay, this looks wonky, something is wrong here. You go up the stack, you try to figure out the context, and then you end, sometimes, often actually, in a thread pool. And then you're screwed, because it's really hard to from there create or find more of the context around. But here you totally can. So if it's all virtual threads all the way down in your application, no matter in which minor operation you have a breakpoint, you can always walk all the way back up to the very virtual thread that is reading from the buffer that is giving you the JSON that you're responding to, if it's virtual threads all the way. So this will allow debugging to be in those situations much more comfortable. I really hope that sooner or later, I don't think the owner ID is exposed, that this will be something that you can navigate in IntelliJ or in Eclipse or in your IDE of choice instead of having to do a thread dump, which, as you can see, can be challenging. Okay, that was that. That was also all the virtual threads I had for you. What comes next is usually the part where we create text blocks and string templates. And as I mentioned before, we're going to skip all past that because the string templates are out and text blocks are boring. What I want to show you instead is that we now have there we go, new folder here, which is a style CSS. Why do we have a style CSS? Let's run the application. Oh, damn. Okay, let me fix this. Another module error. So there I go. It's not that hard. Done that. Okay, now it's resolving all of that. It will, once it's done, it will get all the details, get all the results, get all of those things, and create a very little HTML file for us. This is something that you're probably not going to do in production, right? You're probably going to have, this is a web server or something else, but maybe you're experimenting, or maybe you're just writing a local tool. Maybe you just want to figure out things about your code base or your file system or something. And do you have an idea that presenting this in HTML would be pretty handy? So this is where something like this could come in. So what we have now is we're creating an index HTML. And if we go, We can actually do that on terminal, I guess. There we go. If we go into Surf now and start the JWeb server, JWeb server is a new binary that is part of the JDK for a few releases now. It's just a very minor web server that does nothing but serve the files in directory, and then we can see a little bit more in a second. But that's what it's there for. It's meant for experimentation, demonstration, testing. It's not meant for production. Please, please, please don't put this in production. That's not what it's there for. That was the thing I accidentally opened. I want to get rid of that. That's the slides. This is an empty tab that points at localhost. F5. Yay, we got HTML in my color theme of choice. But how lame is that part? Where I have to run the program and then I have to start the thing. Can we do this programmatically? Absolutely, we can. That's the class that we're currently in here. We can launch the same web server programmatically. So let's do that. That's the simple file server. Create the file server with a new internet socket address. I think I picked 8000. Then we need the directory. We're going to get the server directory that is passed in. Absolutely important. It needs to be to absolute path. I always run into this 3 times before getting it right. So I'm happy I practiced this talk earlier. And then we have the output level. Oh, and also a common mistake is I forget to start. But I think I got it all right now on the first try. And it will do the same thing again. We'll do talk to GitHub and resolve all those pages. It's just a matter of time until they block me. All of us, I guess, then in that case. So if you cannot finish your work today, I'm sorry. I started a simple file server, yes. Yeah, so now I visit local. So it's now hanging here because I'm not sure start, or did I have to make it manually hang? I don't think I had to. I think start is blocking, but you'll see. Maybe not. You'll figure it out. Somewhere here is the reason why the program is still running. The program didn't stop. And I don't have a JWeb server. And I've had 5. Hey, yeah, I still see my website. Did you see how the order changed a bit? That's because it's all hash sets, and it depends on the order in which GitHub replies. So there's also a little bit of instability there. But it's the same content, just in a different order. So we've now launched this very simple, nice utility programmatically. So if you do something like this, that will make your life a bit easier. Now, talking about making your life easier, one last thing I want to do before I run out of time is I want to just be done with IntelliJ. Let's go. Okay, why am I doing this? Because I want to show you that while I've used an IDE for this to program, and I've enjoyed all the shortcuts and all of that, that's all good stuff. I don't want to convince you that you should use something else than the IDE of your choice, but I want to show you that if you're ever in a situation where your IDE is not quite there for you, for whatever reason, maybe you're teaching a beginner, maybe you're logging into a web server, logging into a SSHing into a server, whatever it is, you can now more easily start simple projects from the command line. So what I really want to do basically is I want to say Java, what's it called? GitHub Crawler.java. Now that's of course not going to work because there's no such file here. Let's go search for it, and because this is terrible code completion, I'm going to use L as a command. L is my personal version of ls, -lah. So let's go down into the right tree. Okay, there we go. And now we're going to make it Java. Okay, now I'm telling Java to launch this one file. That's not going to work. We're going to take a little bit of work to do. So the first thing is, and that is really interesting, it found the module declaration, right? It's complaining about a missing module. So that means from the GitHub crawl.java file, which is in part in a source main Java directory, which is unrelated to packages, but then come the package folder, the Java launcher is smart enough to figure out that the root of this is source main Java, and there should be a module, there's potentially a module declaration there. And indeed, it did find it. It looked through it and said, wait a moment, where's JSoup? You said you need JSoup. Okay, good. So let's fix that. -p is -module path. I have JSoup in a jars folder here, so that's all good. Now we get complaints about using preview features. Okay, let's fix those in as well. Enable preview. Nope, that's not how you type that though. Preview. And now we get my program, my code complaining that it needs command line arguments. So that is true. Let me quickly also git eradicate. Git eradicate is my personal throw everything away. And then I want to check out main, I think the last one. Okay, I'm doing that because I have some notes here that I can copy paste stuff from, like now. That's clear, so everybody can see it. Okay, so what I need to add here is just the command line flags that my tool needs, namely the URL to start and the depth, and now we can start it from here. So that means it did all the things, right? It compiled it in memory, it found all the classes that were needed, it found the dependency, it did everything right, it runs the code in memory, from memory. And that means it will be much easier to, as I said, experiment or teach outside of an IDE, without a build tool even, if you're just doing simple things. Okay, that's all that. Let's do a little bit of a recap before I let you go. So, a review. What was that? That was JDK 23 with preview features. Most of what I showed you, you can already use, except launching, like I just did, many source files at once. In the version, in 21, you can only launch one single source file. The unnamed patterns, the underscore, is only final in 22. If you like to live dangerously, you can enable preview features on 21 and use the underscore there. The structured task scope is a preview in 21, 22, 23, and I assume it will only be also be one in 24. For the domain model, we used sealed interfaces that permit the specific subtypes that are allowed. Actually, you know what? I didn't really harp on this, but this is important because it means when we switch on a page, we know there can only be 4 subtypes, namely, after we did this domain modeling with the records, only these. So page was on the left. This is classic UML. Blue is an interface and orange is a record. So, no? Nobody knows, nobody understands the joke because everyone's like, what's UML? What's he talking about? Okay, so when I switch over a page and I mention error page, external page, issue page, and pull request page, the compiler knows these are all the possible cases and it's happy. I could also have said switch over page and let's say I mention only error page, external page, and GitHub page. That also covers all possibilities. So, okay, we relied on this for the switches to be exhaustive. We defined the operations outside of our domain model, and we used destructuring to take things apart, and we used the unnamed pattern to only focus on the things that we really care about. We used a new HTTP client, which builds on the idea that you build something that you can then reuse across threads. And we did not use anything like send async because we use structure concurrency to fire off all of these in parallel and to collect the results later. We used a simple file server to present the results, and we just used the java-p jars main class and args to launch this, you know, if you're in a pinch. Now, José's here. That's really nice. Hi, José. I need to steal from you because my Linux distribution does not support a JPackage. So what we're doing with JPackage is you take a Java application and you're creating an operating system specific bundle, in this case an exe on Windows, and you build it. For example, he has a dumb app here apparently, his words, not mine, where he creates a module.exe, and if you launch that, you get like the the Windows installer. José is super happy about this, very enthusiastic. Let's install all of that. But you can do so much more. This one, for example, is a little bit of a file viewer, of a displayer, it displays images. And it mentions here that I have some association properties that I want to look at. And this will say, okay, when the extension, if the extension is .duke, the file extension is .duke, and the MIME type is JPEG, then this informs the operating system to use this application as the default launcher. And then you get this. Then you get your own application that has a native installer, native to the operating system you're building for, and integrates in something like file opening, for example, to give you, more native applications. Okay, so as a recap, I think that we saw really good domain modeling with records, sealed classes, and pattern matching. Easy structured and scalable concurrency. This was not important here, but this scales really, really well, meaning you can have tens of thousands, hundreds of thousands, more threads than that, maybe millions of threads. Now, whether your services that you contact can deal with that is a different question. There's a good chance that once you make your threads infinite, you don't get 10x performance, you maybe get 10% extra performance because then you have the next bottleneck. Everybody who works with performance knows that it's a series of bottlenecks that you're trying to combat. But at least it removes this specific bottleneck from your considerations. The onboard HTTP client is really nifty, and I recommend you to look into that if it fulfills your needs. And we used a good way to experiment and to package. And with that, I want to thank you very much for your attention. Now, the Java team, the Java Developer Relationships team, which I'm a member of, do all kinds of things online. I recommend to check out dev.java to learn more about how these things work. And if you want to be closer to how Java is improving, check inside.java, check our YouTube channel if you want to hear more of me, or if you've got enough of me now. Anna, Billy, José also make videos there. And if you need to learn on the module system, have a free weekend and you want a headache, there you go. Again, thank you very much. I'll still be around today and tomorrow, and if you see me, just ask me anything. I would be really happy to answer your questions.
All systems are nominal. Initialize Genesis sequence.